Today we are moving on from triangles to quadrilaterals. Quadrilateral is a polygon with how many sides? Well, it's got the word quad in it, so it's got to be 4 sides. Here are, it's just kind of like a quick sketch of the different kinds of quadrilaterals. So a quadrilateral just means a 4-sided figure. Over here we've got parallelogram, and these are all types of parallelograms. A rhombus, a square, and a rectangle are all parallelograms because opposite pairs of sides are equal in length and parallel. A trapezoid is a quadrilateral. A kite is a quadrilateral, which is kind of a type of rhombus, but these are all different quadrilaterals that you should already know you should already know those ones. And another definition is a transversal. That's a line intersecting 2 or more, usually parallel lines. So here's a sketch. So here's one line. Now I'm going to draw another line that's parallel. And the way that we indicate that lines are parallel are with little arrows on them like this. Sometimes it'll be a single or sometimes it'll be a double. But that means they're parallel if you see those matching symbols. So here comes a transversal. It just cuts through them. That's what a transversal is. So it cuts through the parallel lines. Let's go through some new theorems. The first one is the exterior angle theorem, and it's like our last lesson for triangles. We had exterior angle theorem for triangles. So this time we're going to do a quadrilateral. So let's just draw with your ruler always. You are drawing your shapes. This is a quadrilateral, and on the outsides I'm going to give these little names for each of these exterior angles. So that one up top, I'm going to call that one X. The next one over here on the right, I'm going around clockwise, is Y. Down here is Z, and I ran out of letters, so let's go W. There we go. W, X, Y, Z. Those 4 exterior angles, so the exterior means on the outside. The sum of the exterior angles of a polygon is 360 degrees. So for the one we have here, W plus X plus Y plus Z is equal to 360 degrees. That's the same as the one we had yesterday, right? Same as yesterday's exterior angle theorem, part 1. Now let's look at the next theorem, interior angle of a quadrilateral. So we're not going to look at exterior angles now. I'm just going to draw a quadrilateral. And when you draw them, try not to make them squares, rectangles, parallelograms. Just make a weird kind of shape. Here's a quadrilateral. Now it's interior angles. Let's start with A, B, C, D. I've labeled all the interior angles. So this is an angle here that is measured there. These are all measured around the interior lines there, A, B, C, D. And the sum of the interior angles is 360 degrees. So A plus B plus C plus D in this case is 360, very similar to the theorem we just did above. Not the same as the triangle one. Remember, the last lesson, the interior angles of a triangle, A, B, C, that was equal to 180. So this one is equal to 360. Let me erase that. The next theorem we're going to talk about is the C pattern. This is a little different. So I'm going to draw 2 parallel lines, and I'm going to indicate that they're parallel by putting an arrow like this and an arrow like this. That means they're parallel. So when you're drawing parallel lines yourself, if you can't make them parallel, and nobody can by hand, that's what you put the arrows on for to show, well, these are supposed to be parallel. I know maybe they're not, but they're supposed to be. Now I'm going to cut a transversal through those. And let's label these angles here. This little one in the corner is X, and this little one I'm going to call Y down there. So the C pattern says when a transversal, that's the black line, when a transversal crosses 2 parallel lines, the angles that form a C pattern are supplementary. And you remember supplementary from our last lesson. Supplementary means they add up to 180 degrees. So here's a C, if you can see that C right there. I just outlined a C. And let me use a highlighter and show you that. So here's a C like that. So the angles that are tucked in the corner of a C add up to, they're supplementary, they add up to 180 degrees. We've got x plus y equals 180 degrees. But there's another C here. Can you see the other C? Let me just get a different highlighter. Here's a backwards C right here. There's a backwards C. I had two different letters on this side. Let's call them A and B. This one's A and this one's B. Then we can also say A plus B equals 180 degrees. As long as your C is built by parallel lines. That's the C pattern. And the last one for now is opposite angles in a parallelogram theorems. Remember, you don't have to memorize all these crazy titles. What you do need to know is when you get a question that you have to solve, that you can remember that these theorems exist, and you can put them in your own words. So in my own words over here, I would say opposite angles in a parallelogram are equal. That makes more sense than opposite angles in a parallelogram theorem. So you can just write out an explanation. So let's just get a parallelogram drawn here. Opposite pairs of lines are parallel, so these pair are parallel. And these lines are also parallel. Now I can't use the single, that's called a chevron, that little arrow. I can't use this single chevron again because that would say that this one is the same as this one if I use the same symbol, and I can't. So I'm going to double up that chevron there and put another one here and two here. Now the other feature about a parallelogram, of course, is that not only are opposite sides parallel to each other, but they're also equal. So that means this side here is equal to this side here. And this, again, I have to change my number of hash lines because I can't make them the same. The opposite pairs are equal. That makes a parallelogram. Okay, now that we've identified our parallelogram, let's get some angles in here. A, B. Now before I go on, let's look at the theorem. The theorem says that the opposite angles in a parallelogram are equal. So opposite this A, I'm going opposite this A, this must also be A. Because the opposite angles in a parallelogram theorem says that the opposite angles are equal. And opposite this B, so instead of using another letter like a C, that's also a B. And I know that because it's a parallelogram. These are theorems that you can just accept as true. You don't have to prove these theorems. You don't have to prove that the diagonally opposite angles are equal. That's another level of math. We're not proving that right now. We just get to take the fact that they're true and just know that they're true, and we don't have to go into any reasons for that. You do have to do proofs later in high school math. Example 1. Determine the angle indicated by each letter justify. Remember, we have to state our reasons. That's what justify means. First one up here, A. Okay. The angle indicated here is an A. That's the only unknown. So I have to find A. All right, any thoughts? So you should be thinking about this by yourself. I'll stop talking for a minute. Oh, I know exactly what you're thinking. Yes, you're right. The exterior angle theorem. These are all exterior angles. They're all around the outside. So the exterior angles add up to what? 360 degrees. That means if I start with the 100 and then I just write down all the rest of them, there's the 90 and the A and the 84. They all need to equal 360 degrees. And my reason for that is the exterior angle theorem. EAT. I don't have any degree symbols in here yet because I don't need them until the end, just like I wouldn't put centimeters in until the end. So we have some like terms. Back to algebra. We collect our like terms. There's 100 and 90 and 84. We put all of those together. Then we subtract them from 360. And I'm going to skip ahead here. A equals 86 degrees. There's my degree symbol. Okay, so that's the end of the first one. Next one, Where's our indicated letter? Here it is, B. I have to find B. Okay, what clues have I got in the question? Well, I've got some good clues here. Look at these symbols. Now, this arrow right here is kind of fatter. It's actually double. You can't see that it's double because of the way it printed out here is scanned. So this is a parallelogram. It's a parallelogram because we've got opposite sides are parallel and they all have one hash line, which means they're actually all equal to each other as well. So it's a special parallelogram where they're all sides are equal and parallel. We talk about that later in case you don't know what that is. We have one side that's 126 degrees. So remember that theorem I just told you? The opposite angle will be equal to it. So this angle here in the corner, which I have no letter for, is equal to 126 degrees. So I'm just going to write that in there. Remember, when you're doing your homework, you do not write in your textbook. Just do a quick sketch. You don't have to use your ruler. If the question doesn't tell you to draw it, then you just do a sketch without a ruler. Then you can write all over it. So there's my 126. Does that help me get B? Yeah, we have to remember yesterday. Yesterday we learned that, or last lesson, that when you have a straight line, which we have here, a straight line, the two angles that form a straight line add up to 180 degrees. So we have two theorems we're going to reference here. So I'm going to write B plus 126 equals 180. I don't need the degree symbols there. And I have two reasons for that. My first reason that I used was my opposite angles in a parallelogram thing. And you don't have to memorize it. You don't have to memorize the acronym, but you would have to write down something like, this is a parallelogram and the angles are opposite. But I'm going to put P-O-A-T because that's faster. And I used another theorem. I used two theorems here. The second theorem I used, when I drew this blue curve right here, that was from yesterday. That was a supplementary angle theorem. So I used two. We do a little bit of math there, and we get B equals 54 degrees. Okay, let's take a look at C. Now, again, hard to tell. I'm going to put some extra lines on here. These didn't photocopy or scan very well. This is supposed to be a double hash line, and this is a double there. And then we have singles on the other side. But it's not a parallelogram. I don't have any arrows on there. Remember I told you that it has to have these little arrows like this to show that lines are parallel, and they're not there. So it's not a parallelogram. So I know what you were thinking. You were going to go ahead and put a 32 over here, right? You're thinking, well, those are opposite each other. It's just like the last question, but it's not. So what else can we do? It's a hard one. I want you to press pause and think about it for a minute. Okay, did you come up with some ideas? I bet you did. I'm going to show you something here. I'm going to turn this into two triangles. Now, the line that I'm drawing here isn't necessarily cutting this in half. I don't know that this is 136 divided equally in half, and it doesn't look it either, does it? Like this side of the angle right here does not look to be the same as the other side. So I would not assume that that 136 has been cut in half, and it hasn't been. So I'm not going to assume that. But by drawing this, I have created over here two isosceles triangles, 1, 2. Those are both isosceles triangles there, and I have some good stuff about isosceles triangles that I can use. And the main piece that I want to use is if I have an isosceles triangle, this corner here is equal to this corner here, where I put those blue dots, because they're opposite the equal sides. Those two dots are equal to each other. So that's helpful, because when I'm going to look at this triangle right here, I've got a little formula. And even though most of you yesterday could have picked up on this really quickly, or not last lesson could have picked up on this really quickly, now it's maybe a bit more confusing because the triangle looks different, but it's not. Just looking at this triangle right here, just this triangle right here, I know that 32 plus those two dots, there's one dot, I'm going to change that in a second, and there's another dot, that has to equal 180 degrees, right? I know that from my last lesson. So let's, instead of dots, let's call them A's. So 32 plus A, which is 2A, equals 180. That's an A. So we subtract 32 from both sides, and then we divide by 2, and we get A is equal to 74 degrees. So does that help us to figure out D? So you're thinking, okay, I'm going to erase this. Well, it's good to draw your own diagrams because you could scribble all over them. So I'll just erase this blue stuff here. And can I get rid of that blue line? Yep. I'm going to put in that we know A is 74. So that's this piece right here. That's 74. And this is 74. This part, just this part is 74. Whoops, why did I write 5? I don't know. 74. 74. Okay. So where am I going with this? Can you see where I'm going with this? Looking back at this angle right here, this whole thing is 136, and this part of it is 74. So that means, let's call this B over here. B is just this part of the angle. B is going to equal 136 minus 74, because the two of those parts, they look like halves almost, but the two of them together have to equal 136. So 136 minus 74 is 62 degrees. So B is 62 degrees. And that, because this one right here is also 74, then this one, is this one right here also equal to 62? What do you think? So it is, and it's not because it's opposite each other. It's not because of that parallelogram theorem that has opposite angles equal to each other, although this is turning out to be true. But we didn't know that this, we weren't told this was a parallelogram. I know that that other corner is a B because this is also an isosceles triangle. So ignore everything else except the green triangle. Don't look at anything else right now. Let me erase all this mess in here. So just looking at this green triangle, I already figured out that this corner is 62, and because it's an isosceles triangle, that means this corner is 62 as well. Okay, so I'm putting down a bunch of stuff we don't even know. We don't even need. The question didn't even ask us for any of this. Why am I even going there? That's because when I look at my last unknown angle inside the quadrilateral, right here, if I knew this angle, then I could get this angle because they're on a straight line. I can now get this one because, again, looking at the green triangle here, those three angles have to add up to 180 degrees, 62, 62, and this unknown here, whatever you want to call it, x, has to add up to 180. Then when I know this, I also know this. I also have another theorem I could use from our last lesson. There's lots of different ways to do this one, but let's stick with the maybe the easiest one. So I'm going to call this an x in here. Looking at the green triangle, I know that 62 and 62 and x have to equal 180 degrees, and my reason for that is the sum of the angles in the triangle theorem. I didn't put in some of my reasons there, so always make sure you go back and do your reasons up here. Here we have an isosceles triangle theorem. That was the top one, and we actually used that one. We used that one again to get that other 62, but the isosceles triangle theorem gave us the 74, and then we just used subtraction to get the 62. This is just subtraction. There's no theorem for subtraction. Okay, back to the purple triangle. 62 and 62 and x make up 180. So 62 times 2 is 124. 124 plus x equals 180. We subtract 124 from both sides. Well, that was messy. Subtract 124 from both sides. And we get x equals 56. Oh, we're almost there. What's D, finally? What is D? I'm running out of colors, so I'll go with bright red here. These two have to add up to be 180 degrees. X plus D is 180 degrees. We also had another theorem from yesterday that told us that these two angles would add up to give us D. If you were thinking about that, you were right, but it's okay if you didn't think of that. Our final line, D, is going to equal 180 subtract 56. And that takes us back to D. That's the supplementary angle theorem. So therefore, finally, D equals 124 degrees. That was a lot of steps, a lot of scribbling, a lot of mess on my diagram. And if you happen to have a textbook that someone already wrote all over your picture, that's unfortunate because it makes it hard for you to see the diagram for yourself. So I would suggest you redraw it. Okay, there's example 1. Each question got harder than the one before it. Example 2, which is our last one. This is our last slide. Determine the value for x and find the size of each of the labeled angles. So take a look at that diagram. We've got little algebraic expressions here. It's the first time for that. Always solve questions algebraically unless the question asks you to measure it with your protractor, which is very rare, but every once in a while I'll see students just pull out their protractor and measure it and write down the answer. I'm not going to give you any marks for that unless you're told to measure it. You have to actually show the work here. Okay, so what are we going to do? We need to get a value of x. So take a look at that and think about it for a minute. These are all exterior angles that we have information for. What do you think? Okay, hopefully you're thinking about the exterior angle theorem, which says that the 3 outer angles of a triangle or of a quadrilateral are going to give you 360 degrees. So let's write that out. Starting at the bottom, 2x plus 20, that's one angle. And going clockwise, x plus 20. And then the last one is 2x plus 10. So there's my 3 angles, and they have to add up to 360 degrees. And that's the exterior angle theorem. There's a couple of exterior angle theorems. You don't have to specify which one it is. It's an exterior angle theorem. Or you can write out the exterior angles add up to 360 degrees. You could write that out in words. That's fine. Okay, now we have some algebra to do. Let's drop the brackets off of everything. 2x plus 20 plus x plus 20 plus 2x plus 10 equals 360. And now we have some algebra to do. We're going to collect our like terms. So let's look at the like terms. Here's a 2x, here's an x, here's a 2x. What have we got for x's? We got 5 x's there. And before we move things across the equal sign, let's just collect the constants. There's a 20, there's a 20, and there's a 10. That's giving up. Now you could, yes, you could go ahead and subtract them from the other side. You don't have to follow the exact same format I'm doing. That's a 50. And that's equal to 360. Now we're going to bring this 50 over by subtraction. I'm going to subtract 50 from both sides. That gives me 5x equals 310. And to isolate x, I divide both sides by 5. X equals 62 degrees. Nice. Question said determine the value for x. Did it. Done. And find the size of each of the labeled angles. So if x is 62, what does this angle measure right here? If x is 62. So the angle, I'm going to draw a little angle symbol here. The angle that was listed as x, sorry, not 2. The angle, lots of times you have letters and you could put angle A there, whatever your letter was, but I don't have any letters here. So the angle that was x plus 20, we know is equal to 62 plus 20. So 62 plus 20, I'll just put it underneath here, 82 degrees. That's one angle. And then you just sub it into each one, sub it into each angle. You don't have to use this angle symbol here if you don't want to. You could just use you could go like this, angle 2. My second angle is 2x plus 20. That's 2 times 62 plus 20. And that's going to equal 124 and 20, 144. And again, whatever symbol you want for your third angle, you could use you could write down angle number 3. Just be consistent. Unlike I am here, I labeled them all 3 different ways, but just whatever way you pick, just stick with that. My third angle is 2x plus 10. Subbing in 62. You guys are doing this with me, hopefully. You're not just waiting for the answer to pop up. 2x plus 10, 2 times 62 plus 10 is 134. 134 degrees. So we found the size of each angle. Could we test that to see if it's right? What should all those 3 angles equal? Those 3 numbers that we got at the bottom there. What should they all equal? You got an answer for me? Yes, I can hear you. They should be 360 degrees. So when I add these 3 together, I should get 360 degrees, and that's a little check I can do to make sure that it's right, but it's right. So there are some good examples for working with quadrilaterals and with triangles. When you're doing your homework, always go back and look at the examples because they can help you figure out when you get stuck. That's it.